In this video, we'll look at more rules of exponents, namely the product rule and the power rule. We'll start with terminology. An exponent can be used to show repeated multiplication. In 5 to the third power, 5 is the base and 3 is the exponent. In words, 5 to the 1 power is said 5 to the first power. 5 to the second power can be said 5 squared. 5 to the third power is 5 cubed. And to simplify 7 cubed, we multiply 7 by itself 3 times, and we get 343. So let's get practice simplifying expressions with exponents. In the first expression, 3/10 to the fourth power, we multiply 0.3 by itself 4 times, and that will be 0.0081. In the second example, we're going to take the fraction 1/5 and multiply it by itself 5 times. When we multiply our numerators across, we get 1, denominators across 32. So see, when we raise a fraction, a proper fraction, to a positive exponent, the answer becomes smaller than what we started with. 10 to the third power, we get 10 times 10 times 10, that's 1,000. In the next example, we think about what does 5 to the fourth look like? It's 5 multiplied by itself 4 times. And then in the next factor, we have 5 multiplied by itself 5 times. And when we're done, we end up with 9 factors of 5, so we can write it as 5 to the 9th. And we can generalize a rule based on this last example, that if you're taking the same base and you're multiplying it by different exponents, then you add your exponents. This is called the product property of exponents, or the product rule. So let's apply this product property. In the first example, you can see that x is being multiplied by itself using different exponents. So we add our exponents together. And so our final answer can be simplified to be x to the 14th power. In the second example, we have some factors of m and some factors of n. We want to be careful to group those together. Now we can simplify and we get m to the 9th, n to the 13th. So based on what we just talked about, I think you can handle these practice problems. Look back at the examples in the video for some guidance. And some of them you can use a calculator to check your answer if there are numbers. If there are variables like e and f, a calculator won't necessarily help you check your answer, will it? Okay, let's try something else now. Now we're looking at 2 to the fourth raised to the third power. So whatever I raise to the third power, I multiply by itself 3 times. Now 2 to the fourth, as you know, is 2 times 2 times 2 times 2. So I could multiply that out by itself 3 times over. And when I'm done, I end up with 2 to the 12th power. The next example, when you cube something, you multiply by itself 3 times. So I can write out what this means. In my last example, when I square something, I multiply it by itself twice. And so now what I like to do is I like to look at the example that was given and what I ended up with, and I start to see a pattern. Right? So I'm looking for and making use of repeated reasoning, or actually structure as well. I can see that if I raise a power to a power, the end result will be just multiplying the exponents together. So we can write that as a rule. This is called the power of a power rule. x to the m raised to the n will be x to the m times n. So notice I'll multiply my exponents when I raise a power to a power. All right, so now we want to think about a variation of the power of a power rule, because inside these parentheses I actually have a product. So what I'm going to end up doing is multiplying 5 by itself 3 times. X squared will be cubed. And when I'm done, I get 125 x to the 6th power. So here's a new thing to think about, the power of a product property. When you have a product inside parentheses being raised to a power, you can think of it as distributing that power to each of the factors inside the parentheses. So notice m is being distributed to the x and m is being distributed to the y. We're raising y to the m and x to the m. So let's apply this property. We're going to raise everything inside the parentheses to the 3rd power. And when we do, remember you're going to multiply your exponents for a and b. And now we're almost done. The last thing we have to do is just raise 7 to the 3rd power. We know that's 343. Okay, another example like this. We're going to cube everything inside the parentheses. So -2 gets raised to the 3rd power, and y to the 12th. Now you be careful when you multiply a negative by itself. If I multiply a -2 times -2 times -2, I end up with -8, y to the 12th. Okay, and one final variation of this. If I have a fraction that's being raised to a certain power, you want to remember to raise the numerator to that power and the denominator. So everything gets squared inside the fraction that looks like this. So it's 2 squared times x squared over 5 squared. And now just square out your numbers, you get 4x squared over 25. So now some practice problems for you to try based on the examples we just showed.